Good morning, students. Today I am going to handle MOS Controlled Thyristor. This is one of the new device of the power electronics. And here we can see the various evolution of the devices, power semiconductor devices, and till the mid of 1990s. We have bipolar transistors. Then after that they have invented MOSFET thyristors and IGBT devices, and this is what I am going to discuss. It is MCT MOS controlled thyristors, and the silicon carbide technologies is under research. A MOS controlled thyristor is a voltage controlled, fully controllable thyristors controlled by the MOSFETs. It's a metal oxide semiconductor field effect transistor. It is coming under the category. MCT is one of the semiconductor devices which is a latest device. It is a type of power semiconductor device that combines the capability of thyristor voltage and current with MOS gated turn on and turn off capabilities. The device is basically a thyristor with the two MOSFETs built into the gate structure. One MOSFET is used for turning on, and the MCT is used for one MOSFET is used for turning on the MCT, and another MOSFET is used for turning it off. An MCT combines into the features of both the conventional power 4-layer thyristor having regenerative action and MOS gated structure. However, in MCT, we are giving anode as a reference with respect to cathode, with respect to gate, to which all the signals are applied. But in a conventional SAR, cathode is a reference terminal with respect to the gate term signals. The device is mostly used for switching applications and has other characteristics which has it like high frequency, high power capability and low conduction drops and so on. The MCT is a type of power conductor devices which combines the capability of thyristor voltage and current with the MOS gated turn on and turn off. So this is a basic structure of thyristor. It is an MCT. It's a basic structure of MCT cells, and you can see here. This is this portion we call it as an on-FET channel, and these two portions, this purple color, we call it as off-FET channel. The practical MCT consists of thousands of these types of basic cells connected in parallel. This is done in the order to achieve higher current capability of the device. The equivalent circuit of the MCT is this one. So this is the corresponding equivalent circuit of the MCT, and you can see the symbol of the MCT here. And here you look at this. This is one off-FET N channel and on-FET P channel, and another one PNP and NPN transistor. This is the equivalent circuit of the corresponding MCT. It consists of one on-FET, one off-FET and two transistors. One on-FET, a P-channel MOSFET, and other off-FET is an N-channel MOSFET which represents the MOS gate structure. The NPNP structure of MCT is represented by two transistors. As I said, it's an NPA and PNP transistor. The two transistors, here an MCT is turned on by a negative voltage pulse applied to the gate with respect to anode, and it is turned off by applying a positive voltage pulse. So look at this. Here in this case, This is anode and this is cathode, and this is gate and this is cathode. Initially, we started applying a negative gate pulse to the gate. We consider a negative gate pulse of 7 volts is applied to the gate. So how now we will see how the MCT is getting turned on. MCT is turned on by applying a negative gate pulse with respect to anode. That is, otherwise I can say that for turning on the MCT, gate is made negative with respect to anode. Obviously, MCT must be initially forward biased, and then only a negative voltage is applied. With the application of this negative voltage on FET, the P channel FET gets turned on, whereas off FET is already off. Look at this. MCT must here if you are applying a negative gate pulse, initially it is off. So here the voltage, this one is getting turned on. So now because of the negative voltage, with the on FET on, the current begins to flow from anode A through on FET. So here this is the current begins to anode through gate. So here now this is the NPN transistor is getting turned on. So then this will turn on the NPN transistor. As a result, the collector current begins to flow in the NPN transistor. So as off FET is already off, this collector current of NPN transistor acts as the base current of the PNP transistor. Look at this. So here already this off FET is this is turned off. So the NPN and the collector current of NPN transistor acts as a base current of the PNP transistor. Subsequently, the PNP transistor is also turned on, and therefore the base current of the PNP transistor begins to. So here look at this PNP transistor. Now on the PNP transistor is already in parallel with an MCE, which is in the conduction state. During the time MCT is on, base current of the NPN transistor is flows mainly through the PNP transistor because of its better conducting capability. So the regenerative action which takes place, this is already on, and the collector current flows like that, and this gets turned on, and because of the regenerative action, the MCT is now getting turned on. So this is the turn on process. Now coming to that turn off process. For turn off the MCT, the off FET, that is the N channel MOSFET, is energized by the positive voltage at the gate. With the application of positive voltage pulse, off FET is turned on and on FET is turned off. After off FET is turned on, the emitter base terminal of the PNP transistor are short circuited by, this is getting turned on. So the emitter base terminal of the PNP transistor is shorted, and here this is on. Now the current is flowing like this, and again it turns on the, look at this. So after off FET is turned on, the emitter base terminal of the PNP transistor are short circuited by the off FET. So now the anode current begins to flow through the off FET. Further, the collector current of the PNP transistor that flows to the base current of the NP transistor and also begins to decrease. As a consequence, the base current of both PNP and NP transistor now avoid the stored charges in their N and B phase respectively, which begins to decrease. This regenerative action eventually turn off the MCT. So here look at this, already it is getting turned on, and now the collector current is flows like this, and this will turn on the NPN transistor, and the regenerative action is now it will turn off the MCT. So here you have this MCT has different various advantages. It has low conduction drop, fast turn on and turn off times. And switching time is very high, low switching losses, high gate input impedance, which allows the simpler design of drive circuits. Disadvantages: the only disadvantage of MCT is low reverse blocking capability. Now, these are all the applications of MCT. One is MCT can be used to use in the circuit breaker, used in high power applications like high power conversions, MOS controlled thyristor, used in the induction heating, and all kind of UPS is also used in DC-DC converters. Now, VI characteristics of the MCT. You look at this. If the anode is made positive with respect to cathode, when no voltage is applied to the MCT, means it remains in the blocking state. It remains in the blocking state. It allows only a small leakage current. This is a current. It's a small leakage current is flowing into the device. However, when the MCT is turned on, it's remaining the till breakover voltage. The MCT is remaining the offset. After reaching the breakdown, the MCT is getting turned on. So, if the cathode is made positive with respect to anode, either positive or negative voltage applied to the gate, the MCT breaks down at low voltage. This situation is to be avoided. That is, the normal way to turn on the device is to forward bias the MCT by making anode positive with respect to cathode, not cathode positive with respect to anode, and applying a negative gate voltage to the negative voltage to the gate and anode. If the MCT is on, the application of the positive voltage to the gate turns off the device. So, when MCT is in a forward blocking state, it can be turned on by applying a negative pulse to its gate with respect to the anode. So, MCT will remain in the on state until the device current is reversed or a turn off pulse is applied to the gate. Applying a positive pulse means it gets turned off. This is the working principle of MCT. Thank you all.